All right, so today's lesson is a review of slope, also known as the rate of change. And so you may have learned that the rate of change is the change in y divided by the change in x. So when you're trying to find the slope, which is the same thing as the rate of change, you take y2 minus y1 over x2 minus x1. Some people also call this rise over run. A common mistake is putting the change in x on top. You want the change in y on top. Okay? And so we are going to calculate the slope from a graph in this first row here, from a table in the second row, and then from points. Okay? The method is always the same. You just need 2 points. Okay, so in this first example, we have 2 points. And so I'm going to start by identifying y2 and y1. So I'm going to call this one y2 and this one y1. And so notice that in both of these, I used 1 and 1. You've got to be consistent. Okay, 2 and 2. And so y2 minus y1 divided by x2 minus x1 gives us 5 minus 2 over 1 minus negative 4. Okay, don't write minus negative, because that's 2 operations. So that's my trick for you. If you ever see minus negative, that's the same as plus. So write it as minus negative. And so that way we see 1 plus 4 instead of the 1 minus negative. That's going to get really confusing. So minus negative. Okay, and so then the top becomes positive 3. 5 minus 2 is 3. The bottom is a 5. And so our final answer, this is as simple as it gets, is 3 over 5 for our slope. Okay, the most common mistakes is messing up negatives. Just like when we were solving equations, a lot of people just messed up negatives, which changes everything. Okay, on the second graph, they're not giving us points, so we can pick our 2 points. And so always pick good points that are on the lines so that you don't have to deal with fractions. And so I like these 2. And so this point is 0, 2, and this point here is 2, 1. Okay, and so I'm going to call this y2. I'm going to call this one y1. So then this one has to be x1, and this would have to be x2. Okay, so y2 minus y1 over x2 minus x1. y2 is 2 minus 1. And then on bottom, we have 0 minus 2. So the top becomes a 1, because 2 minus 1 is 1. The bottom is negative 2. And so whenever you have one negative in a fraction, you can write it on top, you can write it on bottom. The idea here is that this simplifies to negative 1/2. Whether you put the negative on the 1, whether you put the negative on the 2, or just put it outside, negative 1/2 is negative 1/2. So our slope here is negative 1/2. Okay, for the third graph, they didn't label specific points, but we can label them ourselves. I'm going to pick the y-intercept And I like the x-intercept. Okay, so let's call this y1, y2, x1, x2. So y2 minus y, oh, I'm gonna need more room than that. y2 minus y1 all over x2 minus x1. I like to write the formula over and over again. Helps me remember it. So 140 minus, oh, that was y1. 0 minus 140. Probably should have done the other way, but it doesn't matter as long as we're consistent. And then 70 minus 0. So the bottom will be nice. And so that simplifies, I'm going to draw an arrow down here, equals, we get a negative 140 on top. We get a positive 70 on bottom. When you're simplifying fractions, if they both have a 0, you can cross those off and then look at negative 14 over 7, which is negative 2. I'm going to draw a squiggly line so we don't get those confused. Okay, so negative 2 is our slope. And so something you may have learned is that if you have a positive slope, it's going, let's use, it's going up. Positive slope, it's going up the mountain. If you have a negative slope like you do in the second cases, it's going down, decreasing. Okay, positive slope is increasing, negative slope is always decreasing. So if you messed up a sign, you can double check that, because if I got a positive answer here, I would know something's wrong because this is going down the mountain. Okay, I'm gonna restart the video to do the tables and then restart the video again to do the points. All right, so when we have a graph, you don't have to check to see if it's linear or not, because it's gonna be very obvious because there's a line there on your graph. When you have a table, that's when you have to check because you have more than 2 points. And so those could all fall on a line if we have 4 points, or they could not. Anytime you just have 2 points, you can always draw a line between 2 points. So we're ready to go ahead and calculate slope between all of these. Okay, and so go ahead and label x1, x2, y1, y2. So y2 minus y1 over x2 minus x1. y2 minus y1 x2 minus x1 gives me a 12 on top, gives me a 3 on bottom. 12 divided by 3 simplifies to 4. Love it when the bigger number's on top and it simplifies nicely. No negatives. Okay, on this second example, be careful, we got some negatives. x1, x2, y1, y2. y2 minus y1 over x2 minus x1 gives me negative 3 minus 1 on top, 10 minus 2 on bottom. Negative 3 minus 1 is negative 4. If you're in debt $3 and spend another $1, you're now in debt 4. Use your calculator if you need to. I'm not going to stop you. Okay, negative 4 divided by 8 is negative 1/2. It simplifies to 1 over 2. And then since there's a negative in one place, you still have to write the negative. It can be on top, it can be on bottom. Usually they just write it outside the fraction. Just don't lose it, because 1/2 is going to be an option, 2 is going to be an option, -2 is going to be an option. They know all the distractors. Okay, so x1, x2, y1, y2, and stick around because these examples get harder. So I'm going to try and hurry through the easier ones. Okay, so y2 minus y1 over x2 minus x1. Okay, on top, 2, bottom, -8, simplifies to 1 over 4. There's one negative, so make sure you write it. All right? On the STAR test, they like to put some ugly numbers in here, so I wanted to put some ugly numbers in here. So, label my y's, label the x's, -100, y2 minus y1 over x2 minus x1. -100, and then we spend 15 more. We're now at -115, have $4, and we spend 8. We're now in debt 4. Now on this example, notice there is negative in 2 places. When you have a negative divided by a negative, it becomes positive, and so do not write the negative. Only if it's in one place, like in this example, the -1/2 and the -1/4, you need to write it. Okay, over here, we don't, because it's in both places. And 115 and 4 don't have any factors in common, so that's as simple as that fraction gets. If they have the decimal, you can also write the decimal. Okay, so these last 2 examples, I'm going to get a lot of questions, so I'm going to know if you watched the video to this point or not. x1, x2, y1, y2. Over x2 minus x1. So y2 is a 5, but so is y1. So you probably see something scary. x2 minus x1. 5 minus 5 is 0, and that always freaks a lot of people out. 0 is also a number, so don't be afraid of 0. -7 minus 1 puts us in debt 8. And so this simplifies. If you were to type 0 divided by -8, you would get 0 in your calculator. And that's okay. You can have a slope of 0. What that looks like on the graph, if I were to graph these 2 points, we have -7, 1 to 5. Okay, the first 0.15 would be right here. The second point, -7.5, would be over here. And so since they have the same, I didn't do a good job, since they have the same y values, they graph a horizontal line. And any horizontal line on a graph is going to have a slope of 0. The rise is 0. You didn't rise at all, you're just running. So rise over run is 0. Let's look at what happens on this last example. All right, y2 minus y1 is 13 minus 0. And then on bottom, we have 2 minus 2. So 0 shows up once again, but this time he's on bottom. This does not equal 0. If you type this in your calculator, you're going to get a big error sign because you're not allowed to divide by 0. And what that means is it's undefined. If I tell you to take this set of pencils and divide it amongst 0 people, you would be very confused because you can't divide by 0. And so anytime you see 0 on bottom, it's undefined. And what this looks like on the graph, let's put 13 up here. Our first point, 2, 0 is right here. Our second point, 2, 13 is right here. They have the same x value. And so we know this isn't even a function. It fails the vertical line test because it is a vertical line. And so an undefined slope is a line that goes straight up and down, a vertical line. Okay, and so watch out for the 0 case and the undefined case. The 0 case has the same y's. The vertical undefined case has the same x. So your answer would actually be 0 in this case. Your answer would be undefined in this case. And both are always options on a test. So be careful that you know which case applies to which. All right, so next we are going to find slope from a table. It's the exact same thing, only now our points are explicitly given in a table. You still only need 2 points, and so as long as you know it's a linear table, you pick whichever 2 you want. And so before I start trying to calculate slope, I always make sure the table is actually linear, meaning there is a consistent rate. Okay, and so my y is going up by 1, and then it's going up by 3 here. Okay, while the x goes up by 1 each time. And so I can't calculate the slope on this because it's not linear. And so watch out for those tricks. We're going to be dealing with lots of different functions, exponential, quadratic, and so not all tables are linear. And so this is a trick question. You can't find slope. Slope is only for linear. This is unproportional or nonlinear. Okay, I'm going to highlight that because that's our answer. Okay, for the second graph, notice the x's are going up by 1, 1, and then we jump up to a 2. Over here, the y is changing. To get from 2 to -1, I would have to subtract 3. And then to get from -1 to -4, I would have to subtract 3 more. And then to get from -4 all the way to -10, I would actually have to subtract 6. Okay, and so this is proportional or linear because for every change in the x by 1, I'm changing the y's by 3. If I change the x's by 2, I then change the y's by 6. And so this is linear, and in fact, you can already see the slope. Remember, slope is the change in y divided by the change in x. That triangle is called a delta, means change in. Okay, and so my change in y, each time for these examples, the first 2 points was -3. And my change in x was 1. And so that simplifies to -3. If you want to use the same method we were using on the graphs, you just pick 2 of your favorite points. And so I am going to pick, let's pick, I don't like big numbers. So I'm going to go with 1 and -1 and 0 and 2. Okay, and so I don't want to use those colors. I'm just going to highlight them. We're going to use those 2 points. Okay, and so if I call this x1 and x2, y1, y2, y2 minus y1 over x2 minus x1. y2 is -1 minus 2, and then 1 minus 0. Now be very, very careful with the numerator. -1 minus 2. If I'm in debt $1 and then I take away 2 more dollars, I'm now in debt $3. And then 1 minus 0, of course, is 1. And then -3 over 1 is just -3. If you ever have a 1 on bottom, you don't have to write a 1 on bottom. If the 1 is on top, like over here, you do have to write that. 1/2 is not the same as 2, but 2 over 1 would be the same as 2. Okay, and so our final answer for the second one is -3. Okay, and then for the third table, this is going up by 20, up by 20, up by 40, up by 1, up by 1, up by 2. So this is proportional, this is linear, and so we can do y2 minus y1 over x2 minus x1. Okay, so I'm going to pick this point and this point. So y2, y1, okay, and so y2 minus y1 over x2 minus x1 gives me 40 on top, 2 on bottom, which we know simplifies to 20. Always simplify your fractions as much as possible, because on a test, if you don't simplify, it's going to be wrong. Right? And then next video, we will do the points. All right, so the last thing we're going to talk about is slope from real world problems. And we want to talk about what the slope means in this case. And so remember, slope is change in y over change in x every time we calculate this. And so y2 minus y1 over x2 minus x1. And so your neighbor's dog Patsy ran away from home. You found the dog 60 meters from their house. You decided to walk the dog back to your neighbor's house. The results of you and the dog's position and the time it takes you to take the dog home are below. What is the meaning of the slope? Okay, and so the meaning of the slope, if we were to calculate the slope, we would do y2 minus y1, so we would need 2 good points. And so I'm going to pick the y-intercept, which is 0, 60, and then I like this point too. Let's do 2, 50. So if I call this x2 and this x1, this y2 and this y1, nope, can't do that. Don't switch them. y2 minus y1 over x2 minus x1 gives me a -10 on top and a 2 on bottom, which gives me -5. Okay, so the slope, the value is -5. But to determine the meaning of this, you want to put units on that. And so the y's are measuring meters. And then the x's are measuring seconds. And so the units on this is meters over seconds. I'm going to rewrite it vertically. Meters over seconds. And so we read that as meters per second. And so if we're trying to determine the meaning of this number, we're looking for an answer choice that says meters per second. And so there's going to be lots of distractors. And so here, this says how many seconds you walk, how many meters you walk, how many meters per second, and then seconds per meter. We want meters per second, and so the correct answer is C. And so the shortcut for finding these is to look at your units. Dollars per week. So change in Y would be dollars. Change in X would be weeks. So dollars per week. Let's look at our choices for meeting. How much money per week? Weeks, money, money. Okay, so you're always looking for that per week, something that tells me it's a rate, and so A would be our answer here. This bug on a rug example, not even reading what it's talking about, it's talking about centimeters. Oop, don't want to do that. Centimeters, seconds. So centimeters would be our change in Y. Seconds would be our change in X. So we're looking for a choice that says centimeters per second. Seconds. How far? How many centimeters? Centimeters per second. So choice D. All right, now if we want to